Okay, in this video, we're going to introduce the idea of vector line integrals. So line integrals are also called contour integrals. So we are going to imagine that we have a scalar function phi, which depends on x, y, and z, and we've got a vector function f with f1, f2, f3 as the x, y, and the z components, all of them functions of x, y, and z. Okay, then there are going to be two types of integrals. We are going to talk about line integrals. The first one is going to be phi dr along some given contour. Now remember that r is the position vector xi yj plus zk. So dr is going to be the differential of this, so it's going to be dxi plus dyj plus dzk. So that means this integral here, let's call it I1. So I1, which is phi dr, would simply be the integral of phi times dxi plus dyj plus dzk. If we remove the brackets here, so this is just going to be phi dxi plus phi dyj and then plus phi dzk. Then because the integral is a linear operator, we could actually evaluate these ones separately. So you could do this one and then do this one separately. This is j, and then do this one separately. It's going to be phi times dz k. So this is just going to give us a vector upon integration. We're going to talk about the techniques of evaluating contour integrals in a moment, and then demonstrate them in a later video. The second type of integral, contour integral, that we're typically going to be working on is the integral of f dot dr. So remember we said f is that vector function f1, f2, f3. So this we can write as follows: f1, f2, f3. Then of course dr is dx dy dz, dx dy dz, as we have talked about above, as we've shown it above. And then if we do this dot product here, so this is just going to be the integral of f1 dx plus f2 dy plus f3 dz. Okay, now this type of integral is going to be very commonly occurring in the work that we're going to do going forward, because this is the definition of work done in moving an object along the contour C. So if you imagine this is our contour C, if you move the object from this initial point A to the final point B under the influence of the force field or vector field F. So this integral here is actually the formula of finding work done in moving an object along that contour under the influence of the force field F. Now, how you evaluate these integrals, contour integrals, we are going to explain in the next video. But basically, we simply use the equations of the contour C to rewrite these integrals as your ordinary scalar integrals we will demonstrate in the next video.